In our last lesson, we looked at finding horizontal asymptotes. The one before that, vertical asymptotes. So we were looking at this example in those two videos, and we had so far found the vertical asymptotes. And I have over here on the side kind of a short blurb about how to find those and how to find horizontal asymptotes. And then again, these are over here on the side. These are covered more fully in those videos. So we know that we're going to have a big curve either in that upper right piece or the bottom right piece, and then a big curve over on the left in the bottom or the top along those asymptotes. But we need to figure out where those curves are going to be. So we can use some extra points. Remember that if I know a value of x, I can literally plug it into the function and figure out what y is. And that gives me an ordered pair on the graph. So I can see here that I'm at x equals 3. So if I need to figure out, do I have a point up here or a point down here, then I'm just going to try to find an ordered pair somewhere over beyond x equals 3. So I'm just going to choose x equals 4. And I'm going to let x equals 4, and I'm going to plug that into the original function. And evaluate what y is when x equals 4. Let's see, 16 minus 4 is 12, minus 6. Let's do that again. 16, or you can use your calculator, but anyway, 16 minus 4 is 12, minus 6 is 6, which is 3/2. So that means we have the ordered pair for 3/2 on our graph. If I go back to the graph and plot the point for 3/2, this is 3/2, this is 4, I have the ordered pair right here, the point on the graph. So that tells me that my curve will be up there in that piece of the graph. I have my vertical asymptote here and my horizontal asymptote here, and the graph will be a curve skimming along those. So that's what that piece of the graph looks like. Then I can do the same thing over here. The graph's either going to be up here or down here. So I need to choose a number over here to the left of my vertical asymptote x equals -2. So I see that I have 1, 2, -3. So I'm going to find f of -3. That's when x equals -3, figure out what y is. Plugging that into my function. Oops, -6. So I have -6 plus 1 is -5 over 9 plus 3 minus 6, and 12 minus 6 is 6. So for this ordered pair, I have -3, -5/6. So when I go back to plot that on my graph over here, this is -3, -5/6 is going to be just shy of -1. So I have my ordered pair right there. And then that tells me that my curve here will come along my asymptotes between my horizontal asymptote and my vertical asymptote. All right, so that's the edges. And we're going to know that on any rational function, it's going to have those curves going along between those vertical and horizontal asymptotes. Now, let's look at what happens in the middle part of the graph. That's going to be a little more intuitive. If I have vertical asymptotes And the graph has to stay between the vertical asymptotes. There's only 4 ways it can do that. It can be coming up on this one and down on this one, where we have some kind of a curve in the middle like that. Or it could be going down on this side and up on this side, where we have some kind of a curve in the middle. Or it could be going up on both sides, where we have some kind of a curve in the middle. And down on both sides, where we have some kind of a curve like this. So we're always going to have either this shape, this shape, this shape, or this shape. These are not, just so you're clear, these two over here are not parabolas. They don't have to be perfectly symmetric. So our plan is to figure out which of those 4 behaviors we have for that middle part. And we're going to use some special points, the x-intercept and the y-intercept, to find those. And then we may need to use some additional points as well. Remember, the x-intercept is the value of x that makes y equal 0. Now our function, f of x equals 2x plus 1 over x squared minus x. For this whole thing, y to be equal to 0, just the numerator has to be equal to 0, because remember, 0 over anything is equal to 0, except in the denominator, if the denominator is 0 as well. And we'll look at that more when we talk about wholes. So to find an x-intercept, what we're really going to do is set just the numerator, the top of the function, equal to 0 and find x. Doing that, we have 2x plus 1 equals 0. So that gives us the ordered pair. If x equals -1/2, if I were to plug that in here, here, and here, I don't really care what it is in the denominator, but the numerator will be 0, so the entire function will be 0. So we have the point -1/2, 0. And we can put that back, plot that back on our graph. Here's -1/2. So -1/2, 0 is the point right there. Now, notice that that point is right on the horizontal asymptote. As I mentioned in the lesson on horizontal asymptotes, you can actually cross a horizontal asymptote. It doesn't give a problem there. Remember that a horizontal asymptote is what is y doing as x gets really big. Well, obviously when x is -1/2, it's not really big. It's a small number. So within this middle part here, the graph is going to do something completely different than what it does for the actual horizontal asymptote. So we plotted our point -1/2, 0. Now we're going to go back and we're going to find the y-intercept. In this one, we're going to do exactly the same way that we have always found y-intercepts, and that is to let x equal 0 and find y. So if I plug in 0 into my original function, notice that all of the first part where the x's are goes away, and I'm just left with the ratio of the constants. Remember how we've seen in our other functions that the constant, the number at the end, is always the y-coordinate of the y-intercept? It's the same thing here, but since we have a rational function, we'll have the number in the numerator and the number in the denominator. So we'll end up with that ratio. So that gives us the y-intercept, which is the ordered pair 0, -1/6. Then we'll go back and plot that on our graph. It's going to be very close right here. All right, now that is not really going to be enough information for me to see which of the 4 shapes that I have. So at this point, I need to find some more ordered pairs, just some extra points. And I see here on the graph that I could do something over here to the left of the x-axis, say -1, and then something over here to the right, excuse me, the y-axis, to the left of the y-axis, -1, and to the right of the y-axis, say +2, to be in the correct interval here. So let's find f of -1 and f of 2. And remember, I just chose those numbers because they were kind of in the space that I needed on the graph to figure out where a point would be. You go ahead and plug those in, get your ordered pairs, and plot them. So for this one, I have the ordered pair -1, 1/4. And for this one, I have -5/4, so I have the ordered pair 2, -5/4. All right, let me fix that. That's hard to read. All right, let me go back and plot each of those. So I'm going to plot the point -1, 1/4. And it's just a tiny bit up here. And then I'm going to plot the point 2, -5/4. That's going to be a little bit below. This -5/6 is closer to the axis than -1, and -5/4 is going to be just a little beyond. So x equals 2, y equals -5/4, and I have this ordered pair. Now, if I compare those 4 points to the 4 pictures that I have, I can see that it's going to be the one over on the far left. So I can draw my curve right through those points and then going down. And remember that vertical asymptotes you cannot cross. Those occur because that value of x would make y, or the division by 0 on the function, which cannot happen. So you can never cross the vertical asymptotes. And we have a graph of that rational function. All right. What I'd like you to do is look at the function g of x equals 4x minus 8 over x plus 3. And what I would like you to do is find any vertical asymptotes, its domain, its horizontal asymptote. And remember, you can only have one horizontal asymptote, but you can have more than one vertical asymptote. I want the x-intercept, y-intercept, and some extra points. And then we're going to see if we can graph this. So go ahead and find all of those values. Pause the video. Find each of those things. Draw your coordinate system. Put the vertical and horizontal asymptote on as dashed lines. Plot your points. If you need extra points to see where the graph is, the big curves on the left and the right, go ahead and find some extra points in the appropriate region, and then draw your graph. So go ahead and turn off the video, work on that for a few minutes, and then when you turn the video back on, I'll show you the work. All right. right, hopefully you have done all of this work yourself. Remember, you're learning better if you're doing the work yourself and not just copying what I'm showing you on the video. So for a vertical asymptote, we're going to set the denominator equal to 0 and solve for x. So that tells me that my vertical asymptote is x equals -3. My domain is going to be everything but -3. So -infinity to -3 union -3 to infinity. My horizontal asymptote, we compare the degrees of the numerator and the denominator. So I see here that my numerator has degree 1, my denominator has degree 1. Those are the same. So I look at the ratio, understood 1. So my horizontal asymptote is y equals 4. Now for my x-intercept, I'm going to I'm going to find the 0 of the numerator. So I set 4x minus 8 equal to 0. I didn't leave myself enough room here. I get x equals 2. So I have the ordered pair 2, 0. My y-intercept is going to be the ratio of the constants. So my y-intercept is going to be 0, -8/3. All right, I'm going to go ahead and do the x and y, the horizontal and vertical asymptotes first, and plot the x and y intercept before I do the extra points, because I don't know yet where I need that extra information. So I'm going to rewrite this so I remember it. I can't see my previous page. All right, so I'm going to draw my graph here, draw my coordinate system, and then draw my vertical asymptote. X equals -3. My horizontal asymptote. And I'm doing this fairly rapidly because I'm assuming that you have already done all this work on your own paper and you're just checking your work. All right, so there's my 2 asymptotes. Now I'm going to go ahead and plot my 2 ordered pairs I found here. 2, 0, and 0, -8/3. Let's see, -8/3 is going to be between -2 and -3. So about right here, it's 2 and 2/3, so -2/3, -8/3 is right here. All right, so I know I'm going to have a big curve in those 4 corners, and I have 2 ordered pairs here and here, so that means that the curve is going to be in this corner over here. So I just come up along that asymptote and down along that asymptote. So I need to find out on the other side of the vertical asymptote, is the curve going to be over here or up here? So I have to find an ordered pair that's somewhere over in this region. So see here, -4 is over there to the left of that vertical asymptote. So I'm going to find I think it's G actually. I'm going to find G of -4. Let me double check. Yes. I'm going to find G of -4. So I plug into my function. And I get, let's see, -16 minus 8 is -24 over -4 plus 3 is -1, which is 24. So I have the ordered pair -4, 24. So if I go back to plot that, I see I have -4 here, and I'm going way up here to 24, and I'm just going to go ahead and put 24 up here. I plot that point, and what that tells me is that my curve is now going to be above the horizontal asymptote to the left of the vertical asymptote to hit this point, and I can just sorry, technical difficulties. It thinks I'm trying to change the page because I'm getting too close to the top. So let me come across from here and see what's going on. Oh, I hit the camera. That's what it was. Okay, so I'm back on here, and I draw my curve. And I do apologize for how squiggly these lines are. For some reason, my hand shakes really bad with the Apple Pencil. So just assume that that's a nice, smooth curve there. And you can see what our graph looks like. Our next lesson is going to be about holes. A hole, H-O-L-E, hole, is a special point on a on a rational function. So our next lesson will be about how to find holes and how to recognize when they're going to occur.